Okay, welcome welcome again. And now, uh, today we look at more examples on elimination method. We are still on elimination method. Yeah, I want you to understand it. I want you to be the master of this. You be the master of elimination method. And every time I try to bring you some different examples, the questions that you might encounter in your exercises. So you think, oh, now I know how to solve with coefficient 1 with different coefficients. And now, wow, it comes here. The coefficient is a fraction. So what do? Don't worry. Just be with me and you will see. Now I will go direct because now we know what is a simultaneous equation. We know. And as long as we know what is a simultaneous equation, we also can go faster because things are not that much bad. They are not. You have a really good idea. Fine. It's not time for stories. It is time for something to be done. Let's just go ahead. Now let us look at our solution here. Solution. Yep. Yeah, in order to tackle this easily, we got to change it. I think you have this idea of adding and subtracting fractions, so we got to use that. The LCM here in question number 1, this is our question number 1, and this is in our question number 2. So LCM of equation number 1 is 6. So you got to find the LCM. The LCM, look, this is 5/2. So you got to change this to be improper fraction. And this here is the same as 7/2. So it is 3 times 2 times 2 times 3 plus 1, which is 7/2. The LCM of 2 is 6 again. So it is 6. Oh, good. Now after this, the hectic is over. So just multiply question number 1 by LCM 1 and the equation number 2 by LCM 2. Now it happened that they have both LCM, so it's okay. But sometimes this can have its own LCM and this equation number 2 can have its own LCM. So you multiply by LCM. So equation number 1 by LCM of equation number 1 is equation number 2 by LCM of equation number 2. So here, if you multiply, we are going to get a new equation. And as usual, now I'm going to write it with another pen. New equation. So what goes here is multiply both equations by their LCMs. So the equation is going to look like this. Times 6 here. So we are going to multiply here by 6 and you're going to multiply here by 6. I said do not put those because they look like X, so don't put them. I'd rather put dot. So I'm going to multiply by 6 there and by 6. So this is going to give you 6 times 1/2 is like dividing 6 by 2, so you get 3 there. You get 3 times x minus 6 divided by 3 is 2, then it is going to be 2y equal, mind you, multiply by 6, so this is going to be 6 times 5, which is 30. Now call this equation number 3. It is a new question, so there I got it number 3. If you say it is number 1 again, it will not look like this, so better write it. It's a new question. Here 6 divided by 3 is 2x minus, both equations were minus, minus 6/6 is 1, so this is minus y, and this is equal to 6 divided by 2 times 7, that is going to be 3 times 7, which is 21. So you can do 6 times 7 42 divided by 2, you still have 21, and you call this equation number 4. Now you have what I believe you will know. This is a new equation. This is a new equation, and this is something you are familiar with. We are going to select the simple pair, and it seems to be pair of y here. Pair of y. I told you it is not necessary, but I strongly advise you select the simple pair. If you select this one, it's okay, because we're going to multiply by 2, then by 3 down. Things are fine. But if you select a simple pair, you are going to get the minimal numbers, and which are very easy to work with. So if I multiply, now I just go through, because you know this from the example number from the example number 2. Yes, example, it was example number 2, I'm sure. We do this as we multiply by 2. Oh no, don't multiply by 2 there. We multiply by we multiply by 1, because we've chosen this. We chose this one here as our pair. So the coefficient here is 2, and the coefficient down here is 1. So I multiply 1 here, and down here I multiply 2. That's what we said. So I multiply by 1 on top. If I multiply by 1 here on top, my question is going to be what? Multiply by 1 here, I'm going to get the same question as 3x minus 2y equals 30. This is my question number 5 now. And down there by 2, I'm going to get 4x minus 2y. This is equal to 42. This is my question number 6. Alright, now I have same coefficient, same coefficient, and same sign. So if I have the same sign, I normally subtract. If I have the same sign, I subtract. If I have different sign, I add. So as long as I'm having same, I subtract equation number 5 to 6, or 6 from 5. So I can do either ways. I can go up as well. So here I'm going up, because why? Because these are bigger. If I'm going down, I'm going to get negative. So I'm going to change them to divide by minus 1. So if I don't want, I just look at the coefficients here, and I'm going up. I can go up as well. You can go down as well, but you can also go up. I want to show you different flavors. So 4x minus 3, if you do this way, make sure you do that way, or from equation number 6 to number 5. So 6 minus 5, 6 minus 5, this will give you 4x minus 3x, it gives you x, minus 2y minus 2y minus 2y. Okay, let me write it somewhere. I write it here, and I'm going to wrap minus 2y, the whole thing here. Then minus is there, minus, and this is another minus, so you got to put that minus 2y. So this changes, minus followed by minus becomes positive. So this is going to be minus 2 plus 2y, which is going to neutralize. It's going to be 0. So it is x minus 0, minus because we are taking this, and this is equal to 42 minus 30, which is 12. Okay, 42 minus 30 is 12. So if that is the case, then we have the value of x, that x here is equal to, our x is equal to 12. Nothing to divide, nothing to do what. Our x is 12. Now, if our x is 12, we can put it in any of the equations. From equation number 1 to 6, we can choose any one and put our x. Right? So we have 6 equations from here. So because this is a fraction, we don't want to deal with the fractions, we can just put it here in question number 2. So if we put in question number 2, if you use from 2x minus y equals 21, it is simpler than the other one. I see that 2 times x, 2 times 2, 2 times 12, not 2, minus y equals to 21. So this is 24 minus y equals to 21. And if I what do I do here? I can shift y to the other side so that I can finish things so easily. I do 24 minus y plus y. So I added y here equal to 20 equal to 21 plus y equal to 21 plus y. So I get this. I have y and y goes, and if I rearrange this, it is now 24 equals to 21 minus y, plus y. So I minus 21 this side, and I go to minus 21 this side. So I do 24 minus 21 equal to 21 minus 21 plus y. Whatever I do to the right hand side, you do to the left hand side. When you minus here, you get 3 equal to this goes is equal to y. So this says that our y equal to 3. So our y is 3 and our x is 12. Go to the original. If we go to the original and we try to counter check, we try to check the solution. If you check this solution now, if you check solution, you have what do you have? You have this. You have x equal to 12 and y equal to 3. So put here x is 12 over 2 minus 3 over 3. Is it equal to 5? You just ask yourself. Okay, what is 12 over 2? This is 6. What is 3 over 3? This is 1. This is equal to 5. Yeah, we got it, right? So, C, that is very right. So we got it, and that is how you can do things. Now, suppose we want to check again the second question. This is x over 3, x is 12 over 3, minus y is 3 over 6. Is it equal to 3.5? Is it? Now you check. This is 4 minus 1 over 2, because by 3 is 1, by 3 is 2. 4 minus a half, this is surely 3.5. And we got it right again. So you see that this how. Oh, I'm sure now you are an expert. You are a very good expert of elimination method of solving simultaneous equation. Now I'm happy, and if I move to another method, it will be okay. So soon I'm moving to substitution method. Thank you for watching, and please don't hesitate. Go through again to understand. If you don't, oh come on, these are my contacts. Anytime, please, you can contact, and I will be happily to help you.